Good morning. Our lesson today, changes in motion. For the mass, force and acceleration are related. Acceleration is a result of force. So this is according to the experiment. So you will find this experiment like the cart with the rubber band. Okay. So when the number of the books change or the number of the rubber band change, I can put the books on the cart here, and just when you will find the number of the books change or the number of the rubber band also change, you will find the speed and the distance that the car moved also change. The car accelerates to different speed and therefore travels different distance within the same amount of time. So when you find the rubber band increase, if you fix two or more, so you will find the speed increase and the accelerated increase and also the distance increase. And when also you increase the number of books, you will find the speed decrease and the distance decrease and the accelerate also decrease. Okay. Newton's first law. The law of inertia. We call this law is the law of inertia. An object at rest tends to stay at rest, and an object in constant motion tends to stay in motion unless acted upon by an unbalanced force. So you'll find the object, if it's in rest, it wanted to keep in rest and just to keep its rest state and don't move and don't want to move. Okay, and if the object in state of motion want to keep its state of motion. Okay, and this is according to the inertia. And you remember that when the driver inside the car, just when the car move fast and stop suddenly, so you will find the driver rush forward according to it want to keep its state of motion. So this is according to the inertia. And this is Newton, the famous scientist. Newton's second law, the unbalanced force on an object is equal to the mass of the object multiplied by its acceleration. So you will find force equal mass times acceleration. And also you can calculate acceleration by using this equation, the force divided by mass. When the acceleration increase, the force increase. So this is a direct relation between them. And I told you before that the direct relation, it is a relationship between two amounts. When the first increases, the second increases, and when the first decreases, the second also decreases. This is a direct relation. Okay, so when the mass increase, you will find the force increase, and also when the force increase, the acceleration increase. Now, what about this problem and the answer? Okay, calculating acceleration, total force equal 80 Newton, and the mass of the boat equal 160 kilogram. So I wanted to calculate the acceleration. So the famous rule or the main rule is a force equal mass times acceleration. So when I wanted to calculate the acceleration, so you find acceleration equal force divided by mass. So acceleration equal 80 divided 160 equal 0.5 or half mass or meter per second square. Here you have to put square here. So this two small here. Okay. This is a force, this is a mass, this is a velocity. And we know that before the velocity is a combination between the speed and direction. Without direction, the speed doesn't change into velocity. Momentum. Momentum is a product of the mass multiplied by velocity. So you will find this is a momentum equal mass times velocity. Measuring units is kilogram per meter per second or gram per meter per second. And again, the momentum equal the mass times velocity. So this is the mass of the astronaut and this is a velocity according 0.750 and the mass 60 kilogram. So when you want to calculate the momentum, so the momentum equal the mass times velocity equals 60 times 0.75, 750. So you will find it's 45 kilogram meter per second. And also here the mass 120 kilogram for the artificial satellite, and this is a velocity 375 meter per second. So the momentum equal 120 times 0.0375. So also it's become 45 kilogram meter per second. So the important to know that the momentum is a multiplication or just mass times velocity. Momentum, the tennis ball has less mass than the baseball. So this is a tennis ball and this is a baseball. Okay, so it is would be easier to catch. You would need less force to stop it. The baseball has more momentum than the tennis ball. Why? Because it has more mass than tennis ball. When the mass increases, the momentum also increases according to the direct relation between them. A tennis ball has more momentum if it has more speed. According to the speed, if the speed increase or the velocity increase, so you'll find the momentum also increase. Momentum is important to study the motion of the colliding object. You know, colliding object, just as objects hit each other. And total momentum doesn't change when objects collide. According to the mass times velocity equal mass times velocity. So there is no losing of the momentum. This is called the principal conservation of momentum. Newton's third law. Action and reaction. This is the law of action and reaction. All forces occur in pairs, action and reaction, and these two forces are equal in strength and opposite in direction. So when you press on the wall, this is action, okay, and you will find the wall will exert another force in the opposite direction. This is the reaction. Okay, so this is action and reaction. Also, when you blow the balloon and just you leave it, you will find it raise up, and the air just rush down. So you will find this is the action and this is the reaction. So for every action force, there is an equal and opposite reaction force. When one object pushes another, one the second push the first with the same strength. The push of the first is called action force and the push of the second is called reaction. So the action and reaction. A diver first jumps down on the diving board and then accelerate upward. So you will find it's push down and the reaction up. Okay, according to this is the diver board. Okay, a baseball player swing bat and strike a ball, and then the ball accelerate in the different direction. So this is the opposite direction according to the reaction, the action and also reaction. This include the action and reaction force. The downward force on the board is an action force. So you find the board when just go down, this is the action. When it's move up again, this is a reaction. How are rockets left off? Burning fuel produces hot gases which are pushed down. Action force, yes, you will find this is a burning fuels and just push down, and you will find the rocket just raise up and move up. Okay, so you will find the burning fuel produce hot gases which are pushed downward. So this is the action force. And when the rocket just become upward force, so you will find this is the reaction force. So this is the action and this is the reaction according to the rocket just move upward. Mass, weight, and gravity. So mass is amount of the matter in the object. You know that before that the mass is amount of the matter in the object, and this is doesn't change according to the change of the places. Okay, so your mass on the Earth as your mass on the Mars. Okay, so without any change. And the weight is a force of gravity pulling down. So you will find the weight change according to the change of the place because it depends on the gravity. So your weight on the Earth is different from your weight on the Mars. So the weight is changeable, but the mass is constant. If the mass increases, the force increases. So there is a direct relation according to the increase and increase. If the distance increases, the force decrease accordingly because you will find the two objects become far from each other, so you will find the gravity decrease. So when the mass increase, the gravity increase, but when the distance increase, the gravity decrease. There is an inverse relation, so you will find the inverse relation. It is a relationship between two amounts. When the first increase, the second decrease. This is an inverse relation. It is the opposite from the direct relation. The Earth exerts gravitational force than the Moon. Why? Because the Earth has much more mass. So you will find just the Earth attracts the Moon and they make it rotate around it in fixed orbit or revolve around it in the fixed orbit. Okay, so why? Because the Earth has more mass than the Moon. So the Earth attracts the Moon, not the opposite. The Moon can't attract the Earth or the Earth. Objects with more mass have more weight. The weight changed, but the mass doesn't change, as I told you before. Weightlessness. So, weightlessness, skydivers, or sorry, skydivers, you know, skydivers, this is skydivers, just to fall down from the airplane, feel weightlessness without detectable weight. Astronaut also, astronaut in a spacecraft feel much feeling than the skydivers. Why? Because it's far away in the outer space. True weightlessness. Gravitational force exists among objects in the universe. Okay, so the pull of the sun and the other stars is much weaker when the object is far away from them, because I told you before that when the distance increase, you will find the gravity become weaker and become weak. Okay, so you will find if the object far away from the sun and the stars, so you will find the gravity decrease. Any object has moved beyond this distance region or far away from the sun, so you will find in the position where there is no detectable gravitational pull. Why? Because the gravity becomes very weak. This condition is referred to as true weightlessness. The object still has mass, so the object still has mass, so has a gravity, but it's a um, very little amount of gravity. Okay, It will not vanish or will not end just the object have gravities. The object still has masses. Okay. Okay, again. Yes. So the object still has mass due to the little gravitational pull, just as the object lacks detectable weight. There is no place in the universe where gravitational pull doesn't exist, and an object is truly without weight. Thank you and goodbye.